Good morning students, welcome back to Relief Tutorials. In the previous lecture we have discussed about distance versus time graph and its uses. Let us recap it fast. The first use, that we can find the position of a moving object at any time from the graph. Remember, this is a distance versus time graph, or it is also called as position versus time graph, whatever you say. If the position or the distance versus time graph is a straight line from origin, it means the particle is moving with the uniform motion, means the constant speed. And the graph starts from origin of the graph, means the particle starts its journey from reference point itself. If the graph is straight line again, but not starting from origin, it's away from origin, it means the particle is already at certain distance away from reference point and moving with the uniform speed or uniform motion, whatever. If the distance versus time graph is irregular in shape, it may be like this, or it may be sometimes the curved path like these also. So both these indicates what? Both these indicates the particle is performing non-uniform motion, means the speed of particle is not constant, it is changing. Then if the graph of distance versus time is parallel to time axis, see this graph carefully. Parallel to time axis means what? See, try to understand the nature. This graph indicates what? That look at this, it says that the time is going on because the graph moves in this direction. So time is going on, but the distance remains constant. See the graph. The points are going on the right hand side, means what? The time is going on. Time is passing, but the position remains constant. So it means what? That for example, you are here, this is the reference point, you are here, that this is the car. At 9 AM car is here, at 9 and 10 car is here, at 9 and 15 car is here, means what? The time is going on, but the distance of the particle from reference point remains constant. Distance remains constant, but the time is going on, means the particle is stationary. If you think mathematically, it is very important to understand the mathematical concept also. This is y and this is x. If the graph is like this, it indicates what? It indicates the value of x increases. Value of x increases, but the value of y remains constant. Whatever the value of y, for example, here the value of y is 5, means for whatever the value of x, value of y remains 5 only. This is the mathematical understanding. Here what? For example, the distance of the particle from reference point is 10 meter, for example. So at any time, the distance of the particle from reference point remains 10 only, means the particle is not changing its position. So the particle is stationary. It's very important to understand the graph. The sixth and the most important use we have seen, that we can find speed by finding the slope. How slopey the line is. This is the slope here, this is the graph here. So how to find the slope there? So slope can be found by this formula, y2 minus y1 upon x2 minus x1. Here in this particular graph, it is s2 minus s1 upon t2 minus t1, because on y-axis we have represented distance, and on x-axis we have represented time. Okay, so this is the mathematical formula for slope. This is the important thing to remember. To find the slope, we have discussed already that to find the slope, first of all, we have to select 2 points on the graph, and then only we can go for the formula. Okay, so now the thing is the next type of graph, and that is speed versus time or velocity versus time graph. Okay, so the first type of use, see, now it will be somewhat easy to remember everything. Consider for one of the particle the graph of velocity versus time. This is v and this is t. Now remember, on y-axis we are having velocity. Now let us compare. Comparison. This was distance versus time graph. Okay, and here is velocity versus time graph. Look at this graph. This straight line indicates what? That as the time goes on, distance traveled by the particle also increases. Means distance also changes. The graph goes like this. It indicates as the time passing, as the time is going on, distance traveled by the particle also increases. And as the distance traveled by the particle increases, means what? The particle moving with the uniform motion. But here, if you see, if I draw the graph like this, what do you mean? See, first of all, this is the origin. Origin here, what? Origin means what is 0 here? Time is 0 and velocity is 0. Time is 0 and velocity means speed is 0. So first of all, if the graph starts from origin, it means initially the particle is stationary, because zero speed means zero velocity, means no particle is not moving. For example, on your Activa or on your any vehicle, if the pointer showing the speed is on 0, means what? 0 means you are not moving actually. So first point to be noted, if v versus t graph starts from origin, then the particle is initially stationary or steady. So first point to be noted here, that if the graph of velocity versus time graph starts from origin, then the particle is initially stationary. And what was the meaning here? Here this is showing the position, this is not showing the speed. So here the origin means the particle starting its motion from reference point, because it is showing the position with respect to reference point, and here velocity is there. Now here, if you think the points on the velocity graph, velocity axis is what? 0 meter per second. Velocity is measured in terms of normally what? Meter per second, and time is in terms of second. So these points are what? 5 meter per second, 10 meter per second, 15 meter per second, 20 meter per second. So the speed, it showing the speed, velocity. So this graph indicates what? That as the time goes on, what increases? As the time goes on, velocity increases. Velocity increases means what? Accelerated motion. So if the graph is straight line, here the nature of the graph is straight line, so it means the type of motion is uniform accelerated motion. So the type of motion is uniform accelerated motion, because here the speed changes, and because of straight line, the change in the speed is also uniform. The rate at which the speed changes, that is also uniform. So that is why it is uniform accelerated motion. If I say the graph is like this, so in this position versus time graph, the meaning of this type of graph was what? This type of graph we have seen already. It means what? The particle starts its journey away from origin, means because this was showing the position, but here it is showing the velocity, means initial velocity of this particle is not 0. So particle is already in motion. See, one thing, make it clear in your mind that in the previous graph it was showing the position. Here the position is not described. So we cannot say anything about the position from the velocity versus time graph. Here we can describe velocity. So what we can say, here the graph is not starting from origin. Here you can suppose the value of that is what 5 for example. So it means what, when you start to take the observation, the first observation when you have taken, the particle was already having some speed, means particle was already having some motion. So what we can write here, the graph is not starting from origin, means the particle already in motion. And because it's a straight line, it again means what, uniform accelerated motion. So both these straight line indicates uniform accelerated motion. If the graph is irregular in shape, if the graph is irregular in shape, what does it mean? Irregular shape means what? Non-uniform, because the velocity changes continuously. So it is irregular shaped. Irregular shape means what? The type of motion is non-uniform accelerated motion. Here there is acceleration, but the acceleration is not constant. Here the velocity changes, but that change is not constant. The change is non-uniform. Sometimes the speed suddenly increases, then suddenly decreases, then increases, then decreases. It happens like this. So this is what the non-uniform accelerated motion. The very important and very interesting fact here is, look at this. If the graph is like this, look at here. If the graph starts from this point, it indicates the particle is already having some speed. Now if graph goes like this, what does it mean? It indicates that as the time goes on, velocity coming down. Velocity coming down means velocity decreases. Here if you think 20, then here is 15, and here is 10, then 5 and 0. So gradually the velocity decreases. Now imagine if you are riding your Activa and you are traveling with 80 km per hour. But now the destination is arrived. You are going to home and your home is very nearby. So gradually your speed decreases. So from 80 km per hour goes to 60, 40, 20, 10 and 0. So the graph will be like this. And if the graph touch the x-axis here, if the graph touch here, it means the particle becomes stationary, because at this point velocity becomes 0. So if the graph goes like this, then this type of particle is again what? It's a straight line. So it's a uniform retarded motion. Uniform retarded motion. So uniform, here acceleration will be negative. Here acceleration will be negative. If the graph touch here, this indicates the particle become stationary. If the graph touch the x-axis, it indicates the particle becomes stationary, because at this point the velocity becomes 0. Here if you suppose here the speed is 20 meter per second, then 15 meter per second, then 5 meter per second, then 3 meter per second, then 2 and then 1 and 0. 0 meter per second means the particle becomes stationary. Is that clear? Now last time, if I say the graph is like this, look at the graph, it's horizontal. what does it indicate? First of all, what do you mean by this point? This point means the particle is already having some motion. And now what this nature indicate, that as the time goes on, velocity neither increases nor decreases. If the graph goes upwards, velocity increases. If the graph goes downwards, velocity decreases. But here the graph goes horizontal, means velocity remains constant. If the velocity of particle is 5 meter per second, so at this point 5 meter per second, at this point 5 meter per second, at this point 5 meter per second, so we can say here the particle is moving with the constant velocity. Okay, here if you see, we have seen already that if you think about this graph of distance, this was the distance versus time graph. Here it indicates that distance does not change, distance remains same, so particle is stationary. Here velocity remains same, 5 meter per second. So if you think that you are riding your Activa and you are traveling with 10 meter per second, and if that pointer does not change, so you are moving with the constant speed. You are neither increasing your speed nor decreasing your speed. So these are the 5 different types of graph, and now we have 2 most important uses. These are the uses only, but the most important point, 6th point. If you remember, by finding slope here in the case of distance versus time graph, slope indicates speed. And remember here in the velocity versus time graph, slope means, let us write, we can find acceleration by finding slope. So in the distance versus time graph, slope gives you the value of speed, and here in the velocity versus time graph, slope gives the value of acceleration. So acceleration A is equals to slope, and that is equals to formula y2 minus y1 upon x2 minus x1. Let us say if you are finding the slope here on this graph. So first of all, you have to select how many points? 2 points to select. Okay, this is the first point. So this is the initial point and this is the final point, if you say. So this is the first point. So corresponding to that, the time will be t1, and corresponding to this point, the time will be what? t2. Okay, corresponding to this one, this is what the speed number 1 means. Can I say it is the initial velocity? So initial velocity is u, and for this point the final velocity is v, because this is the initial point. According to graph, this is the first point and this is the second point. First point means initial point, second point means final point. So initial time t1, initial velocity u, final time t2, final velocity v. Now if you put the value here, y2 means final y means v. So it is what? v minus u upon t2 minus t1. t2 minus t1 is like this, means time interval. So I think if you see carefully, a is equals to slope is equals to now v minus u, and t2 minus t1, if you take this time interval as t, so if you remember that v minus u by t is the formula of acceleration. That is why we can say that the slope here in the velocity versus time graph, slope gives you the acceleration value. In any type of graph you can find the slope. Here also you will find the answer in terms of negative, because the graph goes downwards. Here there is no slope. Here the particle travels with the constant velocity. So constant velocity means v is constant, means there is no change in the velocity. So if there is no change in the velocity, acceleration is 0. Is that clear? So this is the use of slope. And now this is very important to you remember. 6th, and this is the 7th important use of this velocity versus time graph, and it is still more important than this one also. For that, let me take one example. Do you understand the motion of train? Consider the train is stationary on the platform. Listen my example, then we will draw the graph for that. The train is stationary on the platform. Okay. Now train starts to move, and at the same time you are starting to take the observations. Okay. At time t equal to 0, the train speed is 0. Time goes on, speed goes on, because the train initially moves slowly and gradually it is increasing its speed. It is not so that it is suddenly increasing the speed and suddenly it moves with the 100 km per hour or 50 km more than that. No. So gradual, because the train is a huge vehicle, so it takes certain time to increase the velocity. So gradually its speed increases gradually from 0 to 5 meter per second to 10 meter per second to 15 meter per second, and it reaches the maximum value. Now the train is outside the city region or on the outskirts, so now it is moving with the maximum speed. Okay, so it travels for a long time with the same constant speed, because we know that in the train there is no speed breakers, no traffic areas and nothing else until the next station arrives. So train can move with the constant speed. On the highways, buses, trucks and the other travels cannot move with the constant speed, because there are certain hurdles are continuously coming on the path. But on the tracks of railway, there is no speed breakers, no other traffic is there, no signals are there. Okay, so what I want to say, that train initially moves with the accelerated motion, because initially its speed was 0. It accelerates its value, velocity increases, and then it reaches the maximum value, and there it travels with the constant speed. There it travels with the constant velocity. And then, for example, the next station is very near. So what do you think? We have experienced that if the next station is very nearby, train starts to decrease its journey or decreases its speed from certain distance before. It is not so that the train is moving very fast until the platform arrives and suddenly the huge brake applies and the short brakes applies and the train stops. It can never happen. If a driver of train tried to do so, the accident can occur on the platform. So gradually its speed decreases, it moves with the uniform retarded motion, and gradually it reaches to the 0 velocity, means again becomes stationary on the platform. Now how can you draw the graph of that? Let us say this is velocity versus time graph. This point is 0, means origin. It indicates that at time t equal to 0, velocity is 0. Now initially the type of motion for the train is what? Uniform accelerated motion, because it accelerates gradually. So the graph will be straight line like this. So let us say the train increases its velocity gradually increases, and it reaches the maximum value. Okay, now see, velocity is not going to increase continuously. It is not so. So after the train reaches the outskirts or the maximum speed arrives, so now for a long time it moves with the constant velocity, means there will be no change in the velocity for a long time. So the graph goes like this. Okay, and now the next station arrives very nearer, so gradually its velocity decreases, it moves with the retarded motion. The graph velocity gradually decreases, and as the platform arrives, its velocity becomes 0 here. So this is the triple nature of graph here in the motion of train. The type of motion for the first type of graph is uniform accelerated motion. So here the acceleration will be positive. Here the particle is moving with the constant velocity. Constant velocity means zero acceleration. And here the particle moves with the retarded motion. So for this part, acceleration is negative. Okay, one more thing, one more use here, that if you find, look at this figure obtained by this type of graph is trapezium, I think, and we can find the area covered under graph. If you find the area of this figure, according to the use, if you find the area of this figure obtained under the line of graph, will give you the distance traveled by the vehicle. So what is the distance traveled by the train? So you have to find the area covered under graph. So this is very important use. We can find distance. We can find distance traveled by a particle by finding area covered under the line of graph. Means if we find the area under this, means if you find the area of trapezium here, you can find the distance traveled by the particle during the whole journey. See, if I want to find that what is the distance traveled by the train, listen to me carefully. What is the distance traveled by the train till it arrives the maximum speed? Means I want to find out the distance traveled by the train when it is moving with the uniform acceleration. So I think the graph will be like this only. Are you getting? For example, let us say let me draw the next graph for the better understanding. Consider this is the graph. 0, 5, 10, 15. These are the seconds. 2, 4, 6. If I ask you that what is the distance traveled by the particle during first 10 seconds only? See, this is a graph of straight line. It is not the trapezium. I want to find distance traveled by a particle in first 10 seconds only. So first 10 seconds means this much. So first 10 seconds means here you can have a line like this. So this is the region covered under graph. If someone asks you what is the distance traveled by the particle in first 5 seconds, so you can have a point like this, and this can be the covered under graph, area covered under graph. So you have to find the, if you have this question, you have to find the area of this region only. And it's one type of right angle triangle. So distance here is equals to area of triangle. Let us say this is A, B and C. So area of triangle ABC. So distance is equals to area of triangle ABC. We know the area of triangle formula is half into base into height. This is base and this is height. So the half into base, the value of this base is 10. And height means this one. So I think the size of this is equals to this. Look at this point is 4. So the length, this length is 4. So this length also should be 4. So half into 10 into 4. So S is equals to 2 1s are and 2 5s are. 5 4s are 20. So 20 meter distance traveled. What I want to say is actually you have to remember the use. Actually, we will have numericals, and at that time we will solve this. But remember this, that we can find distance by finding area covered under line of graph. This is the use only taken in velocity versus time graph. It is not for distance versus time graph. Is that clear? So this is all about the velocity versus time graph and the distance versus time graph. Based on this, we can have some blue color questions given in your textbook, page number 107. Please take out question number 1 here. What is the nature of the distance versus time graphs for uniform and non-uniform motion? So this is the answer here. In the distance versus time graph, for uniform motion, the nature of graph is straight line, and for non-uniform motion, in the distance versus time graph, the nature is irregular in shape. So what we can say here in the answer, the nature of distance versus time graph for uniform motion is straight line, and for non-uniform motion is irregular line. Look at the second one. What can you say about the motion of an object whose distance versus time graph is a straight line parallel to time axis? In the distance versus time graph, if the graph is straight line parallel to time axis, the particle is stationary. Very easy. Third one. What can you say about the motion of an object if its speed versus time graph? Speed versus time graph means velocity versus time graph is a straight line parallel to time axis. Here is that. If the speed versus time graph is straight line parallel to time axis, the particle moves with the constant velocity, means its velocity is constant and acceleration is 0. What is the quantity which is measured by the area occupied below the velocity versus time graph? Means if you find the area below the velocity versus time graph, which quantity you can calculate? I think that quantity is distance. Means distance can be calculated by finding the area occupied under the velocity versus time graph. Here it is. So very easy questions these were. Okay. Page number 112. Exercise. And you have one numerical. Page number 112, exercise. We have one numerical regarding graph only. So let us solve it. See, this figure shows the distance versus time graph of 3 objects A, B and C. Look at this. 3 objects are there, A, B and C, and all these 3 graphs are plotted on the same paper. Study the graph and answer the following. Before going towards the answer the following, let us study first of all it is. This is the graph given to you. See, 3 graphs are there. This first line, this line, look at this, starting from origin, is of particle B. This line is of particle C, and this line is of particle A. First of all, it is given that all these 3 lines are straight. It's a distance versus time graph. It's a distance versus time graph. All these 3 lines are straight. Means if all these 3 lines are straight, means is what? That all these particles are traveling with the uniform motion. One thing. Second thing, tell me, in these 3, or think by yourself, which line is having the highest or the most amount of slope? So I think this one is the most slopey one. the B1. This is slightly less slope and A having the least slope. In distance versus time graph, slope indicates speed. Slope indicates speed. So it means what? The B is traveling with the highest speed. This C is having the moderate speed and A is having the least speed. Okay. If you see, this is the point of intersection of these two lines, B and C. If you see. Okay. So almost, I think this is the point of intersection is 0.6 second. Okay. And corresponding distance traveled is, I think, almost something like 5 or 5.6 or 6, 5.7 you can consider kilometer distance. Okay. It means what? Look at this point. It means what? The B is traveling faster. B is traveling from origin, means B is traveling from reference point. C is already away from reference point. It is traveling, but the B is traveling faster. And after this point, B overtakes C. And here the B overtakes A also. B is traveling faster. Okay. Now see the questions. This is the analysis we have done. Now look at the questions. The first question is, which of the three is traveling the fastest? So we came to know B, I think, is traveling the fastest. This one. So B is traveling the fastest. If you have your textbook, please see. Second, are all three ever at the same point on the road? Are all three ever on the same point? So for that, all the three graphs should be intersecting. So can you see that all three graphs are intersecting at a common point? This is the point of intersection of B and C. Means what? At this distance, at this time and at this distance, both these particles are at the same point on the road. This is the point of intersection of B and A. Means at this time and at this distance, B and A are on the same point on the road. Okay. This is the point of intersection of C and A. At this time corresponding at this distance, both these C and A are on the same point on the road. But we are not having the common point of intersection of all these three. So all these three are not, means they are not anywhere same at the same time on the same point on the road. So the answer here is will be what? No. What was the answer of the first question? That which of the three is traveling fastest? B is traveling the fastest. Now, how far has C traveled? How far has C traveled when B passes A? Now, when B passes A, B passes A means when B overtaking A. Look at the graph of B and the graph of A. So, I think at this point, B is overtaking A. But the question is, when the B is overtaking A, where is C? Means what is the distance traveled by C? So, at the same time, you go towards C graph. This is the graph of C. So, if you see at that time, this is the point where C is. Okay. Now, what is the corresponding distance? It is nearly 7 kilometers. So, 7 kilometers is the distance traveled by C when B is passing A. So, what can be the answer for this question here? That, what is that? How far C traveled? C traveled almost 7 kilometers when B passes A. Same type of question. How far B traveled? How far B traveled when by the time it passes C? Here we have to find the distance traveled by B when B is passing C. We have to find the distance traveled by B when the B is passing C. Here the B is passing C. Sorry, here the B is passing C. Sorry, B and C. So what is the distance traveled by B? So you just go towards here. And the distance traveled by B is nearly 5.7 or something like that. So 5.7 or 5.8 kilometer distance traveled by B by the time it passes C. Okay. One more. Question number 8. It's a speed versus time graph. for this car. Look at this graph carefully. It's a speed versus time graph. Speed versus time graph it is. So look at this point, the first point from where the graph starts. Means here the velocity is 0. Initially the speed increases, and now the graph is going like this. It means what? The speed acceleration gradually decreases, and the graph becomes straight line here. Means velocity becomes constant. No acceleration, velocity becomes constant. Okay, now question number 1. Find how far does the car travel in the first 4 seconds. In first 4 seconds, what is the distance traveled by car? That is the question. How far does the car travel in the first 4 seconds? Shade the area on the graph that represents the distance traveled by the car during the period. You don't have to calculate, just you have to shade that region. So in the first 4 seconds, so as we know that if you find the area covered under the graph, that will give you, so I think here the first 4 seconds, so here you can draw the straight line like this, and you can shade this region which indicates that this is the area covered under 4 second graph. And if you find the area of this figure, it will give you the distance traveled by the car in first 4 seconds. Which part of the graph represents uniform motion? Uniform motion means constant speed. Uniform motion means constant speed. And if you see, the graph become straight from this point. I think from 6 seconds the graph becomes straight. Means from 6 seconds the particle is traveling with the constant speed. So what you can write here? Graph from 6 seconds onwards shows the uniform motion. So this is all about both the types of graphs, their uses and corresponding numericals which is given in your textbook. Okay, now we have one more derivation to do, but that we will do in the next session. Till then, best of luck.